Actually, there's something which I keep notes. I need to send you notes. I've been forgetting that for a long time now. So let me
Yeah.
not put that off. Which notes are left over for me to send you?
So
This
the
alcohol
last one, I
thing.
think, yeah, alcohol thing.
Okay, यहाँ से send करना है क्या?
Sir, a few classes back, you told that LiLH4 will not reduce carboxylic acid, right?
LiLH4 will react with carboxylic acid as acid base. Acid base reaction करेगा, not react
Yeah,
in that.
but yes, but like, what would it form?
Salt.
Sir, but
H
like, I
minus
checked
will
that.
react. What is the salt here? H minus will react with H plus means what will it form? Hydrogen gas.
Yeah, no, what will be the final product? Like, I just want to make sure.
RCO minus La plus. RCO minus thrice Al3 plus.
Sir, I checked everywhere, but then it says it's gonna oxidize between.
What?
It says the LiLH4 will oxidize carboxylic acid.
Oxidize the carboxylic acid?
So reduce. Sorry. Sir, I checked the Essence Annual book also. There also it's.
I'm not so sure. That doesn't seem realistic here. Carboxylic acid, LiLH4.
Even ester.
We'll go by acid base reaction. I'll confirm. I'll check up. I'm now a little surprised, but it has been enough time that I've been out of the market that I should check it up at least once. So I'll confirm this. Carboxylic acids with LiLH4 is a
Like,
question here, right?
I checked that book you told me, that Essence Annual book. There also it told that it
Essence
will.
Sanyal is not a trustworthy book for information
Oh,
at this type of stage. But what have they given? I am curious.
so I checked a few days back. But 1 second, let me.
No, what have they given? I'm curious because they are generally
Yeah,
not really wrong. Usually they are relatively accurate, I would say.
yeah, I'm opening it. Just a second.
So their data might be correct as well. So what have they given as the product there?
1 second. They didn't. I think they didn't directly explicitly give it. But 1 second. If I remember correctly. Mhm. Oh, yeah. I think you're right, sir.
No, what have they given?
Yeah, they gave that thing only. Remember.
They gave
Oh,
what?
the H2 gas, Al H3 minus Li plus. So last time I checked, I said, wait, what? Wait 1 minute. Okay, then my bad. Hmm.
No, we can check again. It is not really that much of an issue.
Sir, but then like it's given like that thing's given, and plus it's also given reduction product will give RCH2OH as well. Yeah.
Yeah, that
Uh,
is realistically possible if you end up doing like with no water. I don't know how to explain it. It is feasible. That is why I'm also not 100% sure. That is why I wanted you to confirm from this book over here. What have they given here as of now?
I'll send a screenshot 1 second.
Yeah, send a screenshot, please. We'll start off with the doubts. Send me the. I think you already started sending. Let me just check out.
I didn't send
No,
anything. It's
send me any.
I sent you what's written in the.
Yeah, I just got that. Yeah, okay. So this is a line ALH4. Yeah, they're given RCOH. Reduction product is RCH2OH.
Yes, sir. Yeah, I saw that and I didn't see anything about last time. Okay.
Okay. Hmm. They are saying that the product which I mentioned is going to be forming, but you're still going to be having the product being formed. The reduction happening is what they are saying.
Yeah.
But you're going to be having a reasonable amount getting wasted, is what they are saying. This is feasible, but my gut feeling tells me it is not just that the product formed is going to be, what to say, good amount of wastage of lithium aluminum hydride is involved. But more than that, I think it doesn't give you a good yield also, because a reasonable amount of the carboxylic acid might end up forming RCO minus, or it'll
Yeah, it says
more or less
1/4
exist
of
as
it.
RCO minus only. So if it exists as RCO minus is quite difficult to basically, what to say, hit with a nucleophile. So if I have to hit with something over here, that is going to be not that easy over here, mainly because this R group is also bulky, and the O minus here will be resonating with this particular double bond oil. It means both of these guys are having delta minus to a great extent. So they will also be fairly bulky groups technically, because lone pairs will be like hanging around nicely. So पता नहीं इसमें I'm not 100% sure this will work nicely, but the next point is very meaningful. That acids are better converted to their esters before reduction with LiLH4. Yes, certainly. If you convert them to the ester, it will do a very good job. Very good reduction. Hoga. So
So
ester
can
might
you repeat?
definitely do a very good reduction. So the carboxylic acid should end here is what my gut feeling tells me. I will confirm. I will confirm if it is exactly that point over there which they are mentioning. 1/4 of the valuable reagent is lost in the formation. Is it only that which matters, or is it what I'm thinking which happens, which is that the rate of the reaction itself is going to be decreasing and it will not do a good reaction? So I'll
Okay.
confirm that thing, but theek hai, I'll check it out.
Yeah. Sir, like
Yeah.
in esterification,
Mm.
no, not esterification.
Mm.
Just
So what is the specific reaction we are considering now?
1 minute.
I start the recording already?
Yes, sir, you did. Yeah.
I did. Okay, cool. Yeah, I've sent you the last 3 classes of notes also. Good. I've been forgetting
Yes, sir.
that for a while, and let's get to the question. Okay, I've sent me a couple of questions.
So
Yes.
here, like when we do the reaction, right? First, this like
62
we'll take
AR,
the
which one are you talking about now?
like the you'll have to do the reaction in order to get both the answers.
No,
Right?
no,
Like,
I don't. Oh, both are actually the same thing. 62A is the question. Okay.
yeah, yeah,
Okay,
yes.
okay, all right, let me have a look at it.
Hmm.
So you're going to be having this reaction here. We are doing Wilkinson's catalyst over here, and then we are going to be doing hydrolysis followed by methanol. Or water. What is that? Methanol or water? What are we doing hydrolysis with? Okay, chalo. Okay. And they're telling us it gets two products, B and C, where C is going to be containing no nitrogen. Okay, all right, okay, all right. So in this here, the Wilkinson's catalyst over here is going to be only reducing the alkene to alkane. All
So,
right.
but then
Hmm.
in our notes, it was given that only terminal double bond gets reduced. Is that correct? Or?
Honestly, I have no idea. Da.
Okay. I just went along
My
with
gut
the
feeling tells me though that what to say, you're going to be having in this particular case here, the double bond should get reduced.
yeah.
Why should the double bond get reduced over here? Because the benzene rings double bonds and the C double bond are much more difficult to reduce. So instead
Hmm.
of reducing those guys, this fellow getting reduced is a little bit more of a bearable type of situation, I would say. Now,
There's a part.
in this here, the advantage of what you have at this stage right now is that they're not really what to say. Okay, let's have a look at the overall thing here. So when you do perform the hydrolysis over there, you're going to be having things breaking down over there, correct? So the
Hmm.
part which is breaking down, which is going to be containing no nitrogen, is going to be your option C,
Yes, sir.
compound C, right? So compound C over here, you're going to be having as the only thing which is going to be directly determining your Wilkinson's catalyst reaction. So
Yeah.
product C here for the above reaction, is it going to be, what is the answer option given there for product C?
B, sir.
Delhi.
B. Bombay.
Bombay or
Bombay.
Delhi?
Bombay, sir.
Bombay. Bombay.
So the thing
Yeah,
does
Bombay
reduce
is
the,
correct. Yeah, Bombay will be correct. Yeah, Bombay is the correct
like
answer
it,
there. Yes, tell me.
there is a possibility that this Wilkinson catalyst does not even reduce the thing, right? Like we should just
See,
ignore that.
sincerely speaking, I have no idea about what to say, how exactly Wilkinson's catalyst is going to be exactly operating. Now, in
Okay.
reality, though, it is expected to operate in the sense that it is going to be attacking the less, what to say, populated region, the one which is going to be more freely available. It will go attack. But when there are no regions available, what is there to say that it will not attack what is available?
Yeah.
Right. See,
Yeah.
effectively, what we know is that it attacks the least sterically hindered location or the corner wala fellow as much as it can. Right.
Yeah.
In this case, there is nothing else available. Now, there are other things available tantalizingly, but it cannot eat it. Right. There is
Hmm.
benzene. It's like you're
Yes,
a
sir.
beggar outside a five-star hotel.
Yeah.
So even something which did not originally look attractive to you starts looking attractive.
Hmm.
No, anyway,
Yeah.
coming back to the point here. So acidification here is going to be something which is like this. Okay. Now, in this here, the Wilkinson's catalyst there, realistically, I will let it stay as that I am not exactly 100% sure what is the way in which it attacks. It doesn't make a difference. I don't need to know. Neither do you. Now, next up,
So
what
no,
is
in
the
this
doubt?
question I did that.
Only this was a doubt?
No, sir. That's one of my.
No,
So
in
this
this year,
was
this
one.
was a doubt.
Yeah. No, there's one more. So like this reaction, like A product will be the same thing without the double one, right? So the basically an ester. I mean, yeah,
A
ester.
product is going to be the ester without the
Ester,
double
right?
bond on the C double bond C. That's all.
Yes. Yeah. Now when we're doing hydrolysis of an ester, right? Why is it that like we get an carbo, sorry, anion, right? Like why does it have to stay on the like?
This is your ester.
Yes, sir. Yeah.
Okay, now tell me for this ester, what is going to be the thing which you're talking about over here?
So now like NaOH, it's basic medium. So OH minus would come and attack the carbon. Bond goes up, comes back down again.
Right, this is what you get.
Yeah, and then the
Hmm. Then what
bond
happens?
comes back down, and then OR dash leaves.
Right.
Yes, sir. Yeah,
Effectively, that's what's supposed to happen. This is also going to
yeah.
be reversible effectively, giving you R, C, double bond O, OH.
Hmm.
Now, in this here, this will of course not stay exactly as it is as well, because this is going to be with R dash O minus technically. You can put it like this. Is this the correct mechanism though?
That's what you're given.
No, this is actually not the correct mechanism. The actual correct mechanism goes like this. You're going to be having RC OH, you get an O minus, and you have got your OR dash. Okay.
Yeah,
Next step, what will be happening is an intramolecular acid base.
between the hydrogen.
So we'll end up having this O minus and this OH over here. They will effectively end up, what to say, accepting H plus. That is, this H plus can basically go to this O minus, or this can technically react with water molecule and accept a H plus from there,
Hmm.
wherein it will end up becoming something like this.
But
Okay.
that's not stable.
Now you will end up having the elimination happen.
Oh,
Now, there are many different ways of playing this out over here. You can effectively end up, what to say, doing it in this fashion, or you can also say something like this will happen. All of these will be reversible effectively. So because they are
hmm.
all reversible, none of them really matter. You can say this fellow shifts inward, this guy gets out. So you get this.
Yeah,
Then
same thing as before.
at the time that this guy is leaving, this RO minus comes and attacks this. This will effectively result in another RCO minus now. plus an R dash OH.
Okay, so that's more stable. The
Effectively, it's all hogwash, sincerely speaking. Now, why am I saying it doesn't really make a difference? Simply because everything is in equilibrium.
sir, but
What do I
then the
mean by that?
options.
No, what does it?
Uh,
See, think for a second.
yeah.
Stop thinking about answering questions now.
Hmm.
Okay, stop thinking about answering questions for a couple of minutes. Answering questions comes as a supplement to understanding what's happening. Why am I saying none of this matters? Simply because all of this is in equilibrium.
Yeah.
So what is it that we observe? We observe all of these species as it is. I see RCO minus, I see RCO, whatever that RCOH, OH, OR dash, a little bit of that is there. I will also be seeing R dash OH. I will also be seeing a reasonable amount of the RCOH
Initial.
and R dash O minus also. I will have
Hmm.
all of them present at the same time. Depending on how much of each of them is present, then only we can basically start coming up with theories as to what all are happening. Now, why am I saying
Hmm.
all of this is possible to happen? And I don't really care? Simply because it doesn't make a difference, internally speaking. You're going to be having all of these various equilibriums playing out over there. Now,
Hmm.
depending on how you write the setup of the equation, you'll have different equilibrium constants at play though. I don't
Hmm.
think I made sense to you yet, but it is okay if I
No,
did
but
not make sense also. But just I understand this at this stage over here. You don't need to worry about what are the internal steps which are going to be happening. All you need to
hmm.
understand here is that you're going to be having a nucleophilic addition type of attack happening from OH minus and some
Hmm.
sort of nucleophilic elimination happening where the R dash O minus is leaving. As simple as that.
Okay.
Giving you this as a product, more or less.
Hmm.
Now, the next game over here is going to be what you are about to ask me. What were you about to ask me?
I was about like uh, my main question was why does this carbo what do you call this COO minus stay as an anion and the OH becomes an alcohol or R dash O minus.
Because you're going, oh, that last step is the real question for you. Huh?
Yeah, everything
So
else
the
fine, sir.
last step is the real question. Okay, all
Yeah,
right. So the
but
last
I
step
think it's
here,
huh,
what is happening is a simple acid-base reaction here. The R dash O minus, which is present over here, is a stronger base
the
compared to the
stronger. Okay,
RCO
that's right.
minus. And the
Hmm. Okay.
RCOH is a stronger acid than the R dash OH. So it will happen in forward
Forward
direction, this
reaction.
reaction more.
Exactly. Okay.
Obviously, it will end up giving you this as the product here, RCO minus and R dash OH. Right.
Hmm. Yeah.
Fair.
Okay. Yeah, that's right. Okay, sir. Hmm.
Next up.
I think it's
There is one critical point which you should understand though. Esterification reaction does not happen in basic medium. It only happens in acidic medium. All right, ester hydrolysis happen in both basic and
both.
acidic,
Yes.
but esterification only happens in acidic. It does not happen in basic. They will use that to play around in exams usually. Watch out for that.
Okay. Mm.
Okay, so we're going
Okay.
to be having some fellow PCC, something. Okay, all right, okay. So now this is a question which goes like this. Pay attention here.
Yeah.
So we are having this compound available right now. Now, this compound here, when I'm hitting it with PCC, what will you be getting? We'll be getting the two locations here. What is PCC going to be doing? It converts aldehydes, it converts alcohols to aldehydes and
Alcohol,
ketones.
aldehydes, and ketones.
So you end up getting this.
Yeah.
Now, this is my compound A. Now, this compound A is going to be treated with this fellow.
Yeah.
Now, ethylene glycol, when it is going to be in the presence of H plus, what is this particular thing going to be doing? This is going to be effectively doing nothing but acetal formation. All right. So this is going to be doing Have you already done the reaction of aldehydes and alcohols?
Aldehydes and alcohols.
No. Okay, so let me discuss that.
Don't think so. Aldehydes and alcohols. Oh, yeah, I had a doubt on that as well. Yeah.
So let's quickly discuss this. If I'm going to be having, say, a particular compound, like say an aldehyde here, all right, I'm going to be reacting it with, say, methanol. What is going to be happening is, in this particular case here, this fellow will end up performing a regular nucleophilic addition reaction. Okay, wherein you're getting product obtained now as R, C, you will get an OH over here, and then OCH3 over here, and a hydrogen here like this. Okay, after 2 steps. It is not 1 step. I'm just combining it and putting it as 1 step because I am lazy. Okay, no other reason. I have no other reason for it. I'm just lazy about it. It's going to be 2 steps actually. First step is going to be O minus, and then the CH3OH will lose the H plus. Acid base reaction again. You notice acid base reaction is also going to be completely reversible.
Equilibrium.
So reversible steps, you'll be getting this. So 2 steps, both reversible. Okay, you get this. This compound is called as the hemiacetal. Now, this is very, very much unstable. It easily goes back to give you the aldehyde or ketone if you simply add excess water. Already add excess water, it will end up going back to hydrolysis, it will go back to the aldehyde or ketone. Now, this is going to be happening in the presence of H plus, usually dry, not in the presence of water. Because if I said, as I said just now a while back, you add water, what will it do? It will do the backward direction. It goes straight away in the backward direction. So you need to have it in the forward direction here. So you keep it in the forward direction idea here. So dry H plus will push it in the forward direction. Next up, if you end up doing some more CH3OH in the presence of more dry HCl, what happens in that particular case is even that OH which is present there will basically end up leaving. Again, this will be reversible 2 steps. And the product obtained will be this. This product is called acetal. Okay. Now, the interesting thing here is this. Acetal is a little bit more stable than hemiacetal. All right. So stability-wise, in some cases, acetal is a little bit more stable. All right. So acetal usually, acetal also undergoes hydrolysis very easily, by the way. All right. But acetal is little bit more stable. I should not put to slightly more stable than hemiacetal. Now, this slightly greater stability than hemiacetal is especially true in basic medium. So in basic medium, this is going to be one of the key advantages for things over here. Now, why is this a useful technique to basically have? Well, it goes like this. If I have, say, molecule, like say this. All right, this is an aldehyde ending. This is a keto ending.
Yeah.
Okay. What I'm going to be doing is I'm going to be reacting this fellow with ethylene glycol in the presence of dry HCl gas. What happens in this particular case is exactly what I just talked about a while back. You're going to be having, in this particular case here, what is the first step which I just showed you over here? This first step here, nucleophilic addition.
Yeah.
So this nucleophilic addition which is going to be happening is going to be having steric hindrance as the main factor, right?
Delta
The
plus.
factors which is involved over there. So
Hmm.
you're going to be having in this molecule here, if you're considering, this is one location, this is another location to be attacked, correct? So this location, this location is an aldehyde. So which location is offering more steric hindrance here?
Ketone.
Ketone. So this fellow will attack which one, aldehyde or ketone?
Aldehyde.
Aldehyde. So what happens now is we'll end up having this fellow going and attacking the aldehyde not once but twice to form the acetal in this case. First it will form the hemiacetal, then it will form the acetal.
So two more.
Because there are two OH groups in the same molecule here, correct?
OH groups, yeah.
So it will first form the hemiacetal and then it will form the acetal. So what will be the hemiacetal first? I'll show you the hemiacetal here and then I'll show you the acetal as well.
Sir, if the instead of a carbon to the ketone, if there's some like electron withdrawing group, then where would it go?
Think. It'll go there, right?
But like, what if it was like NO2?
What type of electron withdrawing group can you put over here? This is your location to put it, correct?
Yeah.
Can I put a chlorine here? If so, what group is it then?
Acid.
Halide.
Acid halide, yeah. Exactly.
So you can, but you'll have to basically understand it changes the property itself completely.
Okay. So, okay, fine.
Okay, now in this particular case here, you'll be getting product first obtained being like this.
Oh, not yet. Yeah.
Okay, you first get this hemiacetal. Next one, what will happen is you'll end up having this disappearing and you'll have this also disappearing to an extent. So let me redraw this part now. I'll be having something like this. This will be the product formed over here. This will be the acetal which is going to be formed after this step here. You understand the idea here?
Yes.
Now, this fellow here, if I react it with say LiAlH4, what will I be getting as the product now? I'll be having this location undergoing reduction.
OH become, yeah.
Right. So I'll be getting product obtained as carbon, carbon, OH, carbon, carbon, and this fellow will be intact as it is. Now, if I perform, say, hydrolysis, LiLH4 is generally done in basic medium, right? So the acetal is going to be stable in basic medium. So it doesn't react with the LiLH4 part there. Now, when we perform hydrolysis, H3O plus, what is going to be happening is we'll be getting product obtained like this. And 1, 2, and 3. The aldehyde group basically got protected in the entire process. So if you look at it from the starting here, from here to here, what did we do?
Looks like
we selectively reduced only the keto group. Selectively, we reduced the keto group while we protected this aldehyde group completely.
Okay.
So this is acetal, this thingy is basically a method to protect the aldehyde group usually.
Okay.
You understand the idea over here?
Yes, sir.
So let me put it down over here. So the aldehyde is protected.
So this is when only when reaction with ethylene glycol, or like
only
when it reacts with ethylene glycol, or like similar things. Like,
sorry, repeat again.
Is this the does the aldehyde get retained only when it reacts with ethylene glycol? Is it like a property of ethylene glycol, or like do other?
No, it is not just ethylene glycol. It is any geminal, diol, thiol, dithiol, those kinds of things. So it can be a
Okay.
dithiol also.
Hmm.
Anything which can basically form this kind of capping. So you can think of this
Hmm.
as capping. Another name which you'll be using or which you'll come across in chemistry nomenclature for this or associating with this is called capping.
Hmm. So this is similar to the ozonolysis one, right? Does that have anything to do with the, like
No, your technique is
ozoniding?
similar because they both look like houses. That's all.
Exactly. But
No,
like, okay,
no.
okay,
That house is not a single story house. Like this one is a single story house. It's a double story house.
2, 3
See,
was.
it's not that. There's like two separate shapes there. There's a middle
That's
bond
true.
there between them.
Ah, yeah, that's true.
We're
Yeah,
not going to
CC
go now. We're
bonds.
not going to go anywhere now. No. I'm not going
Okay.
to go back again here. Now, in this case here, this is going to be the idea over here for now. Now, anything else you have to go back to over here. So in the question which
No.
we were talking about over there, what is going to be happening here?
Uh,
What will happen here?
aldehyde retained. The other thing is
Aldehyde gets
ozonized.
protected,
Yeah.
right? So the aldehyde will get protected here through the process, and we'll be doing some steps on the other fellow.
That
So what
gate
are these
becomes.
steps being performed on other fellow? Grignard reagent is the attack over there. You understand what's happening now?
1 second. Just.
So we're going to be
CH3.
protecting it. So in this process here, we'll be getting product obtained as, let's say, so we'll have protection done here. So we'll have this, and this fellow in the next step is reacting with Grignard reagent. Okay, so this is compound B. This compound B is reacting with Grignard. CH3 MgBr. Now CH3 MgBr, the Grignard will of course solely go and attack this carbon here, no other location. So the product it will be producing now will look like this.
So why won't that ketone turn into a alcohol as we did before?
Mhm.
Wait, sir, could you go back to the reaction you wrote just now?
Mhm.
Stuck. Okay, nothing.
Acetal, the advantage is it is stable in basic medium.
Yes, sir.
And most of your LiLH4 Grignard reagent reactions are done in basic medium. Oh,
Yeah.
for a second, it is raining. Give me a second. I have to go. Yeah, sorry, dude. There were clothes hanging outside. Yeah, where was I? Can you hear me, dude?
Yes, sir. Yes.
So do you want me to continue on with the question or you already solved off with the question?
Oh, yes, sir. I'm fine with the question. Yeah.
You done with the question?
Uh, just give me a minute.
So in this here, the Grignard will basically end up attacking here, while this location is fully protected. Yes, huh?
Why are you keeping that? Okay, because we didn't react with LiLH4, you're keeping that structure as it is. That
Yes.
penta.
LLH4 ke saath, that
Okay.
flow will not react. It is stable.
Okay, I was thinking that. Okay, my bad.
And in the next step, in the hydrolysis step there, we will have the entire thing going back to normal. Meaning we'll have, see, the hydrolysis is the second step from B to C. Pay attention to that.
Hydrolysis, second step. Yeah.
So you'll get back the aldehyde there and then sodium borohydride, NaBH4 and ethanol. So now when you do NaBH4, NaBH4 will clinically go attack only this location here and not anything else. So you'll be getting final product obtained here like this, where you'll have an OH and a carbon here, and the neighboring fellow will have a carbon and then OH like this. And this hydrogen will be from NaBH4.
So
It's
that
going to be just
so it's not the NABHR which is turning that cyclic thing into aldehyde.
it's not the NABH4 which is turning the cyclic thing into.
Aldehyde.
Of course not. It is
Okay.
hydrolysis.
Okay. Understand.
This is the one.
Okay. So yeah, got it.
See, this is the one which has converted this guy here.
Yeah, got it.
Okay, next up. How is your inorganic preparation coming along? Any doubts in inorganic?
Not really, sir. No.
Any theoretical questions which you have come across which have not worked out properly in inorganic?
Sir, nothing as such. Sir. Like no, sir. Yeah, there's
So
nothing.
inorganic is going quite smoothly.
Yeah, as of now. Sir, for questions, would you recommend I just do the PYQs or the VKJs
Huh?
for questions? Inorganic.
Huh? Why would you want to solve
VK.
questions in inorganic, man?
Okay. No.
Sincerely, I'm asking. I
Or,
mean, realistically, give me a second. Just get the trouble.
Hmm.
See, what level of questions are you looking to solve in inorganic? That's the question. What level do you want right now? Are you aiming for JE advanced level or JE mains level first?
Mains first.
Yep. Then why the fuck do you need to solve questions at this stage for inorganic?
Okay.
Yeah, right.
Yes, sir. So then for advanced, what do I have to do then?
Advanced के लिए you will have to practice, right? Advanced के लिए the practice is going to be old JE advanced questions mainly, and of course you'll have to practice what to say a little bit more than that. Certainly, initial thing is going to be old JE advanced questions because not the single option correct type, the more interesting ones which show up, which are comprehension based, which are like what to say, A giving B, giving C, giving D, giving E, giving F, giving that type of nonsense. So when it comes to JE questions, they are definitely a cut above. You need practice in inorganic as well. But JE mains level, no. You especially do not require much practice. If you sit and get your theory done properly, thoroughly, you'll be clear, good to go, so to say.
In my sir's notes, there are like a bunch of reactions. Like, for example, he there are quite a few reactions, sir. Like, for example, like PCl5 with some different things. Like, how important are those? Like, are those
Tell
required
me
to
the
memorize?
reagent, tell me what you're asking. Give me the reactions directly, no?
PCl5 plus P4O10 gives rise to 6. So repeat.
So you're talking about PCl5 plus P4O10,
Yeah.
correct?
Yes.
I'm guessing you're getting product as something like this.
POS. That's it. Yeah.
Yes or no?
Yes, sir.
So now, have I ever heard of this reaction? Heck no. But can I guess the fucking product? Yes, I can.
Hmm.
You need to get to that stage.
Okay. Hmm.
You understand the idea over here? Now, in this case here, why was I able to guess the product that directly? Would I have guessed like this if it was PCl3? No. Why? Because I know for a fact that this is +5, this is also +5. The product is also
Oxidation.
+5.
Oh, okay. Hmm.
There is no oxidation shit happening here. This is just internally displacing each other to get into a more stable scenario, which is like a mixture. That's all.
Hmm.
All I did was that this is going to be phosphorus pentoxide. This is what, this is the anhydride of what? Of H3PO4.
H3PO4.
Right. And
Then
H3PO4 is going to be something which is going to be a proper +5 acid. Fairly stable system, very stable acid. Not a problem at all. So now this guy is not really a problematic situation, excepting it is a dehydrated situation. So ideally speaking, this P4O10 is not unstable. This PCl5 though, that is unstable. Why is PCl5 unstable?
because
This reaction is
he's
happening.
in
Why is this reaction happening? This reaction should happen because one of the fellows is forcing the reaction into happening.
Yes.
Which bugger should force the reaction into happening here?
PCl5 because it's the one suffering.
Why? I already gave you the goddamn answer, but why?
Is the chlorine atoms are too big? Chlorine atoms are big.
No, not just that.
Not just.
It's got two different types of bonds. Right?
Sir, what?
It's got two different types of bonds. All the chlorines are not equal there. There are two separate different types of chlorine atoms here. Which is the real problem. They're not equal. So now they would prefer to go into a system. The chlorine atoms will now prefer to go into a system where they are individually all treated equally, even if they are ill-treated by a different atom.
Okay.
You understand the idea here? They want to be treated equally. That's all. Because they are triplets. They are the same thing.
Yeah.
If somebody is getting benefit or not, doesn't matter. खुद का खानदान type का ही होना चाहिए.
Yeah.
So you're going to be having the POCl3 basically is going to be the solution they end up coming up with. Oxygens don't care actually. Oxygens don't care much. Oxygens, the P4O10 is not the main cause of the reaction over here. The PCl5 is the main causative agent of the reaction in this case. And you get the POCl3. Now, do you need to know these reactions? No. But should you be able to get the products? If you're asked, yes. Can they ask you in a JEE advanced paper? Yes.
Oh.
Yes. And can they screw with you even more and make it worse, where they're giving you, say, A plus B gives you C, C with something gives you some other reaction, and something. They can do all kinds of funny business.
Yeah.
So, advanced, yes, it is very much realistically possible that you might get asked questions based on things. But it is not really that bad, sincerely speaking. It's okay. You don't need to really, if you have extra time, you can memorize. Give me a few other reactions. Let's try a few.
There's some weird. Okay.
So this, yeah, you don't need to memorize this, but I think you'll not forget it now this time.
I want to read this time.
Now, next one.
Yeah, this is. Sir, 3PCl3 plus SOCl2.
SOCl2 के साथ. So is this that weird one where you get this S2Cl2 plus POCl3 type of crap?
Not S2Cl2, but POCl3 is correct.
What else is obtained there other than POCl?
PSCl3 plus PCl5.
PSCl3
plus PCl5.
PCl5.
Yeah.
No way of guessing this type of shit. And yeah, you don't need to know about these kind of reactions. How many times are you going to be asked these? It's a game of probability. Yes, there is a chance that it might be asked. But there is enough chance that there's going to be enough shit in organic chemistry to ask in A giving E, B giving C, giving D, giving E, giving F. Only if they can't find shit there will they ask in this kind of thing. And even in this, you should still be having other ways of getting the other options there. For instance, in this here you said POCl3 is one of the products, then PSCl3, then PCl5. Correct. I would have probably had difficulty guessing this PSCl3. I'm still not convinced that we can get PSCl3 and PCl5. Still not fully convinced. Because here sulfur is going from +4 to -2. And phosphorus, you are saying, is going from +3 to +5.
Exactly.
I don't think this will happen. I don't think this reaction is correct. My gut feeling tells me this reaction is not correct. S2Cl2, on the other hand, that is realistically possible. Sulfur is going to +1. Not till -2. +4 and the +1 is reasonably possible. But -2, tough. -2 is tough. -2 is tough because sulfur is just a little bit more electronegative than phosphorus, not that much more electronegative. It should not be able to oxidize phosphorus to +5 while reducing itself to the -2 stage. I'm not sure of the products over here. Let me put it this way. I don't trust your answer.
Okay.
So, I'm not sure of my answer also. I'm not saying my answer is correct.
So just a second.
Yeah. Take up. It's okay.
Yeah.
You back?
Yes, sir.
How does this look if I open this now? It just looks like brightness. Okay. Okay. All right. So next, what are the reactions? So this reaction, I don't even trust the reaction whether it's correct or not. So I don't even care about whether it's necessary sincerely. My gut feeling is that it is really not needed right now. What else? Next up, next reaction.
C6H5N2Cl plus H3PO2.
That's needed. Not here though, in organic chemistry.
Organic. Okay.
So what is C6H5N2Cl?
That's diazonium
Yes.
chloride.
H3PO2 के साथ, this is going to be a fairly interesting and important reaction. You'll end up having this guy undergoing oxidation, and you'll end up having product basically becoming phosphorescent +3 or sometimes phosphorescent +5 also. But this fellow, the benzene ring, will undergo reduction here to give you product as benzene. You get benzene and you'll get phosphorus either in +3 or phosphorescent +5. Depending on the hydrolysis stage which you're using. What is the answer? What is the equation required there?
It gives 2 benzene plus H3PO4 plus N2 plus HCl.
So you're going with phosphorescent +5. So H3PO4 is what they're going with. N2, of course, is going to be coming out. All your reactions will give you N2 gas.
Okay.
I'm not so sure though, because I remember literature where we do get H3PO3 also. Both are obtained. So not 100% sure if we get only +5 there, because my gut feeling tells me H3PO3 is also obtained partially. Not so sure. But so, that doesn't make a difference. But yeah.
Okay.
Next up. This reaction you don't need in this chapter. So you don't care about it here.
How do I know which
you care about it in benzene, not here. In benzene, you care about it. In inorganic, you don't give a shit about it. They should not ask you this in inorganic. But I think you have phenols and benzene, diazonium chloride and shit, nah.
No, sir, only alcohol.
Only alcohols. Then yeah, you don't need to care. You should not care logically. Next. Not
So,
for
how do I know which ones to study
which
and to
one?
care about? How do I know which ones to care about and which ones not to care about?
I think I already told you, no. You don't need to give a shit about your teacher's notes at this stage. You need to care about only NCRT at this stage. Because at this stage here, you should not be preparing for JE Advanced.
Yeah.
Preparing for JE Advanced, teacher's notes alone are not enough. You need that plus a little bit of extra supplementary also. So, how do you decide? Choice is very clearly made. Now you are reading this so that you get an edge in your internal exam. So, sincerely speaking, in your internal exam, nobody can guess it up. Depends on who is setting the paper. Okay, घाट में कितना problems है, irritation है, how irritated is that person that they have to take it out on the students. Depending on that, उसके हिसाब से काम होगा. Now anyway, next up, give me a few more reactions. Let's quickly at least discuss make it snappy and faster so that we can quickly talk about which ones you need to bother so much about and which ones you don't need to worry so much.
So TeF6.
Tellurium, you don't need to give a shit about anything.
Okay. KMNO4 gives rise to K2MNO4 plus MNO2 plus O2.
KMNO4 gives you K2MNO4, MNO2 and O2.
Yeah.
Decay of KMNO4. Thermal decay.
Yeah, exactly. Yes.
Yeah, you need to
Preparation
know
of
that, God's sake. But not in this chapter. Which
oxygen.
chapter are you doing now? Group 15 and group 16. Why the hell do you need this over here?
Preparation of oxygen.
Yeah, production of oxygen. You don't need to know all the individual products there, but remember it like this. Any oxidizing agent, if you heat that sucker, it will produce oxygen gas.
Nitrogen also.
Basic game there. That's why it's called an oxidizing agent. You heat the fellow, that oxidizing agent will somehow or the other produce oxygen gas. That's the game there.
Same with nitrogen.
Of course, nitric acid will basically, on heating, give you what? Nitrogen dioxide gas and oxygen gas.
Yeah.
Next up, water also, of course.
Water, yes. Yeah. Sir, PCl3 plus 3LiAlH4 gives PH3 plus LiCl plus.
Is that a problem really, or is it obvious?
Pretty
it's obvious, no? You're doing alcohols for God's sake.
Yeah. Okay, my bad.
It's not your bad. You just need to start thinking about inorganic the same way you think about organic.
I can. Okay.
Common sense. So if you're having PCl3 reacting with LiAlH4,
reducing agent. So
reducing agent, it will give you pH3. Quite obviously. And what will happen to the chlorines? You go for the lithium and the aluminium. So you get LiCl and AlCl3. Job done.
Okay. Yeah. That was the bad. Okay. P4 plus HNO3 gives H3PO4 plus
Stop. P4 plus HNO3. How do you proceed here and understand the reaction? Now, HNO3. What type of a substance is HNO3? Powerful goddamn oxidizing agent? That's its identity?
Yeah.
Yes or no?
Yes.
So, its identity is, it is the biggest, one of the biggest oxidizing agents, one of the biggest bullies around. What will it do? It will extract all the electrons from phosphorus. Phosphorus will go from 0 to +5. +5, what is the stable form of phosphorus available? H3PO. But depending on the amount of water available, I'll be getting H3PO4. If not H3PO4, what are the other stable +5 forms of phosphorus we know? We have HPO3.
HPO3, yes.
Which is an anhydride version of this. And you also have P4O2. So these are the possible products with HNO3. Depending on the amount of water available in the medium. Now, what will happen to the HNO3 once it has done its job. Depending on the amount of HNO3 available, I will have the products also obtained, correct?
Yes, sir. Yeah.
If I have enormous amount of HNO3 available, what will happen in that case?
All of them could form.
So think of
All
it like
together.
I have huge amount of HNO3. What does huge amount of HNO3 really indicate?
It'll stay
Hmm?
excess.
Excess. What does excess
I mean,
also indicate here as another possible way of looking at it?
it'll
Concentrated is
remain.
another way of looking at that shit there. Correct?
Yes. Yeah.
Now, if I have concentrated HNO3, that basically means I'm going to be having enormously large amount of HNO3 available per unit volume.
Mhm. Yeah.
So, what will be happening here? I'm having a large amount of nitrogen in +5.
Mhm.
So, each nitrogen in +5 will be having just about enough time to go give a smack to the phosphorus. Take some electron and go away. They'll do some conveyor belt type of shit.
Mhm.
Why? The problem there is this. NO3 minus becoming NO2 is one thing, where the nitrogen in +5 is going to become +4.
Hmm.
Then what happens is this NO2 can still go and end up becoming nitrogen in +3, which can still go down and become nitrogen in +2, then nitrogen in +1, and so on and so forth.
Okay.
But for the nitrogen to go in this process till this end over here, it will do that only if all of the NO3 minus are gone. NO3 minus is the biggest bully. Only after all the NO3 minus are satisfied will the NO2 start doing its shit. So if I have concentrated nitric acid, all of
Yeah.
my reactions involving concentrated nitric acid will end with NO2 gas. Why?
Okay.
Because I have a tremendously large amount of NO3 minus available in the medium.
NO3 minus. That'll get oxidized.
So
Yeah.
the
That'll
biggest
lose.
bully will be the only fellow who will keep doing the reaction, oxidation reaction.
Hmm.
NO2 will not get a chance. NO2 is a reasonably good oxidizing agent, but not good enough. Not compared to NO3 minus.
Yeah. Makes
But
sense.
so if I have concentrated, I'll be getting products as H3PO4 and NO2, main products.
Hmm.
Other products are loose fellows, we don't care. Water, shit, I don't care. These are my two main products, depending on the amount of water. If I have concentrated, the problem is this though. Do I have water or do I not have water?
No, we don't have.
Good. So will I get H3PO4 really? H3PO4 is with water.
Yeah.
Correct? What
Yeah.
do you think I'll be getting? There is a little bit of water, because HNO3, when it does end up acting as oxidizing agent, NO2 mil jayega, oxygen nikal jayega, but you get a little bit of water out there from the nitric acid itself. So I don't have a chance to get P4O10. P4O10 is like destroy, nothing, no water, nothing like that.
Yeah.
So like
Completely.
I get this sucker. So if I have to write the reaction between P4 and HNO3, what would be my guess to get the products over there? If I was given concentrated nitric acid, how would I guess that? I will say it will probably give me HPO3 and it will give me NO2 gas. If it is dilute HNO3 though, then
Just a second.
yes,
Someone's at the door.
please. Okay. So when you're going to be having dilute nitric acid here though, you're going to be having conditionalities appearing there. Nitrogen is still powerful, either in the NO2 stage or in a nitrogen +3 or +2 or +1, whatever it is, it's quite powerful as an oxidizing agent. So you will still be getting phosphorus going till like say H3PO4 or HPO3 stage. In this case, mainly it will be going to H3PO4. One second.
Yeah.
Typing already. Yeah. So you're going to be having H3PO4 obtained here mostly, but at the same time, the other product can be NO, N2O, and if you are having extremely dilute nitric acid, the usual product obtained will be ammonia or some kind of ammonium salt, usually. If you are having extremely dilute nitric acid, used as an oxidizing agent. You have group 15 this time, na?
Yes.
So let me just quickly give you this is basically nitric acid, not phosphorus now anymore. So if you're looking at reactions of nitric acid, concentrated nitric acid will only give you NO2 gas as a product. Reduction. Dilute nitric acid, depending on the amount of dilution and the other player, the other substance which is undergoing oxidation there, can give you anything from NO, N2O, N2, and NH4 plus.
Water.
Not water. NH4 plus. Nitrogen is the one which is undergoing reduction, nada?
Yeah.
I'm only looking at nitrogen.
Okay. My bad. Yeah.
So it can go from +5 to +2 to +1 or 0 or -3. So the most dilute form will generally go for this. So for instance, when will you get that NH4 plus? Zinc. If I'm hitting it with, say, very dilute nitric acid, or say iron, it's a very dilute nitric acid. In that case, there is a chance that I might end up getting NH4 plus.
Yeah, it was given. Yeah. Yes.
Sorry?
Yes, sir. Yeah.
You understand the idea here, right? So it depends on what you're using over there. Zinc and iron, of course, will undergo oxidation over there to become the corresponding +2 ions over there. Iron might also become the +3. Depends there.
Yeah. Yes, sir.
You're going to be having this analysis basically is going to be applicable when it comes to nitric acid. If it's more diluted, the more it will go towards a lower oxidation state. If it is in more concentrated form, it can do nothing. It will, because the biggest bully is NO3 minus. Other NO3 minus will basically end up clogging all the electrons. They will not let the NO2 or the other forms take the electrons. NO3 minus will take the electrons exclusively. It's basically the same as acid base. Acid base, what is happening? We have discussed this before once or twice, I think. If I have a mixture of acids and I add a base, which acid will react with the base? Which acid strongest will react first? Correct?
Yeah.
Why? Because it is absorbing protons over there.
Exactly.
What is being absorbed here? You're having electrons getting absorbed. It's the same basic principle. In
Yeah.
that case, protons are absorbed. Here, electrons are getting absorbed. Nothing else.
Yes.
Same game, but different substances getting absorbed over there. Different subatomic particle is basically getting absorbed effectively. So in both cases, the same principle applies. When you are going to be having multiple sharks, the biggest and the strongest shark eats first. As simple as that. Now, next up. What other reactions have been frustrating you? Nitric acid, I can understand.
Yeah, there are a bunch of nitric acid ones.
I think this should sort out a reasonable number of your nitric acid queries to some extent at least. And how you should remember nitric acid reactions for redox is you should only remember the redox part. If you're expected to get the other products over there, you can always balance the shit out, redox balancing over there and get the job done. Do not remember final reactions, only remember the redox products there. That is, what does nitrogen become? What is the other fellow becoming roughly? If the other fellow is guessable, don't even remember that. Only remember what nitrogen becomes. That's it. Job done.
Yeah. Especially the ones with when you're reacting with metal, then you would only have to check which state the metal thing is.
Correct. Yes.
Okay.
So if it's going to be lead or copper, I don't need to give a shit. I know they are going to go into +2 only. They're not going to go into some superior state over there. They're going to go to +2. So how does it matter what they're going to be doing there? I just need to know what the nitrogen is going to become mainly.
Okay, yeah.
What other reactions are troubling you in inorganic so far? You have sent a question already, no? Let's just quickly have a look at the question and realize you had sent a question earlier. Give me a second.
I sent one previously.
So you've sent a question on on organic there.
Yes, sir.
So you're having glycerol and you're reacting it with acetic anhydride. In the above reaction, molecular formula of glycerol increases by. Okay. So what is going to be happening is you're going to be having in this particular case here, this happens. This will get out as a molecule of acetic acid. And you will have the oxygen now connecting up with this carbon. As it's just going to be normal nucleophilic addition elimination. So you'll have nucleophilic addition happening. This oxygen, 2 electrons will go attack this addition followed by elimination.
Okay.
2 steps. So you'll have 2 steps, reversible fully. 2 steps. You're going to be having, first is going to be nucleophilic addition elimination. Not 2 steps, sorry, 3 steps. My mistake. 3 steps here. First step is nucleophilic addition. Second step is going to be nucleophilic elimination. And third step is acid base. After all of these 3 steps, all reversible, you'll be getting product obtained here as something like this. You'll have this. This will be still OH. This will be still OH. And I'll be having the other product obtained as CH3COOH. So this is with 1 mole of acetic anhydride. Now when you're doing with 3 moles, the product will become something like this. So you will also be getting 3 moles of acetic acid as product obtained over there. All right. So what has happened over here? You will also be getting another thing, 3 moles of water also eliminated out. Moles of water? Water, sorry, acetic acid, nothing else. No water, sorry, my mistake. So you're going to be getting this is the product here. So what is the question going for over there? They're asking above reaction, molecular formula of glycerol increases by how much? So the molecular formula increases by 3 times this, but it is also going to be decreasing by what? 3 hydrogens.
3 hydrogens, yeah.
All right. So not 3 times this, sorry, made a mistake here. It increases by 3 times
Only
this.
Yes.
But it decreases by 3 hydrogens there. So it's going to be 3 into, we're going to be having CH3CO minus 3H or plus 3H. Right? Increases by, sorry. Increases minus 3H.
Yeah. C3H6 O3, yeah.
So you're going to be having C3H6
C6
and O3.
C6.
So it is C6H6O3. Which is which option, Ra? Delhi.
Yeah, that's what's given.
Okay, next up. Any
Sir,
other
what,
doubt you have? Yes, huh?
sir, what's a trans-esterification reaction?
Trans-esterification reaction. Let's say I have this RCOO R1. Okay.
Hmm.
If I react this fellow with say R2OH in the presence of H plus,
Hmm.
I will have an equilibrium now where I'll be getting product as R C double bond O R2 plus R1OH. It will be in equilibrium. This is going to be a trans-esterification reaction.
Hmm.
You understand the idea here?
Okay. Hmm.
It
Sir,
is
what?
not going to be giving you any one product. It will be in equilibrium only.
Hmm.
Okay. Next
Okay,
up.
sir. Sir, like, what if the instead of alcohol, it was in carboxylic acid?
Where
Instead of R2OH, if it was an R2C double bond OH,
carboxylic acid, nothing will happen.
I'll send the question once.
I understand what you're asking, Ra. I'm saying nothing will happen.
There was a
So let's say we are having RCOO R1 plus say R2COOH. Okay, yeah. This is the question, right?
Yeah.
So nothing will happen here. This is not that good at performing nucleophilic addition. Nothing will happen, Ra.
Like in the solution, it said the RD, the carboxylic acid would perform
What
nucleophilic
will it
addition.
perform?
Nucleophilic addition.
How?
The lone pair of oxygen.
Which oxygen? This one?
Yeah, that one.
This guy is in resonance.
Yeah, that's what.
This is not available.
Hmm.
This is not a good donor. No, that doesn't make sense. Are you sure?
Yes, sir, that's what it's.
Which book? Send.
MS Johnson.
Doesn't sound feasible. Send. That is not correct. I doubt they would have given it like that even.
Sir, there's a chlorine also. I don't know if that'll make any difference.
It does make a difference. What is the substance given there?
I'll send it.
Acid halides are notoriously more reactive. So yeah,
It's not like acid halide, but
let me have a look. Wait. Ethyl 2-chloro 2-phenyl acetate. Okay, 1 more. Acetic acid. HCl 1.5 hours. Okay, that is why this shit is happening. Look at the conditions they have given here.
yeah.
So yeah, this shit will not happen under normal conditions. If you're going to be putting it under dry HCl and heating, in that case, what you are literally doing is you're stripping this fellow first. So if you do this with dry HCl heat, what will this fellow become? This will become RCOH separately and an R dash or the R1OH basically. Then you are going to be having this mixture reacting with this. So no, this is not a meaningful transesterification. This is the more meaningful transesterification reaction. Under those observed conditions, anything can happen. Right? You are heating it with HCl gas, dry HCl for 1.5 hours. I'm not going to be even commenting about that reaction. Anything can happen. That is, everything can happen. This is a typical transesterification reaction, which is going to be very much possible when you're going to be having, what to say, an alcohol available in acidic medium. Tiny bit of acidic medium is sufficient, not that strongly acidic and all, but it is only with the alcohol, not with the acid.
So this
Next,
will come in carboxylic acid chapter, or like
which one?
transesterification. Like we didn't learn it. That's why.
It is something which you will be learning in carboxylic acids and derivatives.
Okay.
Next up,
Mhm.
it is reaction of ester. Na?
Yes, sir. Yeah.
Ester में आएगा.
Okay, sir. Next one.
That capping of aldehyde and ketone is a very useful reaction, along with the acetal and hemiacetal. So make sure you are familiar with that.
Yes, sir. Yeah.
Useful and internal good. External also acetal hemiacetal will play a very important role. As in for J advanced and all.
Yeah.
You sent another? Cool, okay. Given are the structures of cyclic D-glucoside, moles of HiO4 consumed in the extent Y respectively. Okay, now, so you've learned HiO4 reaction or you've not learned?
Learned, sir. Yeah.
Learned, now. So HiO4, what is it doing really?
What is it doing? Like oxidizing.
Where does it attack?
Oh, like polyhydroxy.
I have vicinal diol attack.
Yes, yeah. That's one case, and then there are like a
That's
few
not
more.
one case, that is a type of case.
Yeah. Yes.
So HiO4 here is going to be predominantly preferring to attack that type of shit.
It also attacks adjacent OH and adjacent keto group. Or like,
Give me a second, I just want to go. Yeah, where was I? Yeah, the glucose thingy. Okay, huh? You cannot answer this one as of now. This is a far more complicated question than what you can answer at this stage. Let me just quickly, or have you learned how HiO4 works properly?
Not really, but he just gives a trick to just break the bond and then put two watches.
Yeah, that is something which you can certainly do at this stage here. But with the compounds given there, how do you do that is the real question. Nah?
Sir, I'm okay with the first one. Second one, I have a doubt regarding the between. There's a wait.
You should have had it out in the first one also. They're both the same.
No, first one was fine.
How was first one fine?
There are only three places. Where else would it attack? I mean, we were told that we won't attack ethers and esters. I mean,
read the question now. What is asked there?
Oh, moles of moles of
Which one are you talking about here? A or B or C?
A, sir.
A. Okay. So A, you are looking at how many moles of HiO4 are involved in the reaction there, correct?
Yes, sir. Yeah.
Okay. So what is the problem there now?
So the second example, Y example, I was thinking that, okay, I thought it was an aldehyde group there. Okay, it's not aldehyde group on the top.
Yep, it's not an aldehyde group on the top.
Yeah, my bad. I thought that should also do a reaction with adjacent OH, but then no, that's.
But if you undergo that fellow on a hydrolysis there, that will become an aldehyde group there. Right. So now, how? What is the reaction really?
So what do you mean?
This is why I said you cannot do this right now. The answer is wrong here. Okay, the answer is wrong here. Given answer is what here exactly? What is given here?
First question, A option.
A option. 2 is given, huh?
3 2 is given.
3 2 is given. Delhi 3 and 2 are given. Then that is not a problem. Now, what is the problem there for you then?
No, I just now realized my mistake. I thought there's a keto. I thought it was a ketone group at the top, so I thought it should be 3,3.
Okay, both the groups at the top are what really? They are acetals. Look at them again.
Wow.
They are acetals. Okay.
Yes.
So they are not really going to be ketone or aldehydes. They are acetals basically. So acetals are not going to be reacting is the idea over here. You understand the idea here?
Okay, yeah.
So the real question is about acetals. So the job here, why it is a little bit more complicated, why did I say it is not really in your reach right now, is because glucose is this actually. So more or less, this is going to be a representation of glucose. So when you're going to be having glucose being something like this over here, what happens over here is you're going to be having acetals and hemiacetals forming internally. That is, this fellow can form a hemiacetal here, or this bugger can form a hemiacetal with this also. So depending on which one is going to be, in this case here, they are showing for 3 of them. They are showing for 3 of them. This is also shown here. Forming hemiacetal with this guy is also shown there. So you can effectively have different types of hemiacetals being formed. Now, when you're going to be having different acetals and different hemiacetals being formed, you're going to be having different systems being obtained over there. So here, the CHO here, they have formed a hemiacetal with the ROH from outside already, and with an internal one also. So you're going to be having hemiacetal already with this, and then finally it becomes an acetal. So it's a lot more complicated than what you think. Don't bother with this question for the time being. So for the time being, if you're looking at it to solve it, do it exactly the way you did. Don't care about the acetal or hemiacetal there. Acetal and hemiacetal are not going to be reacting. Keep them and proceed on. As simple as that.
Yes, sir. Yeah. I sent the next one.
Yes. Succinic acid. So, have I or have you all, are you already familiar with this?
Like in nomenclature once.
Yes. Do you know what this is?
Oh.
So, oxalic, malonic, succinic.
Yeah.
You're going to be having succinic acid being this guy. It's a dicarboxylic acid. Without knowing what that acid is, you can do nothing. So this is going to be succinic acid heating. Succinic acid will end up giving you the anhydride.
Yeah, that.
Which will basically look like this. When you hit it with ammonia and you heat it, you will end up having this oxygen basically getting replaced by a nitrogen, NH. And when you end up doing bromine and KOH, that is a reaction which you do not know at this stage.
Okay.
All right. This is bromine and KOH. That is a reaction you do not know. This is called as Hoffmann Bromamide reaction. You have not learned this here. This is going to be a reaction in acetamides. So for now, don't bother with this shit at all. Okay. Yes, it is that same Hoffmann dude. Different Hoffmann is not existing. Same Hoffmann, same asshole, but different chapter. So it's called Hoffmann Bromamide reaction. So till you come there, we are not going to be touching it. So this is the reaction which we have sent. We have sent 2 questions. Okay, second is also like that. Okay. What is the product of the following reaction? We're hitting this with osmium tetroxide and we are hitting it with some kind of a peroxy acid, no, normal carboxylic acid. and then alcohol and OH minus. Okay, so normal hydrolysis. Okay, a little bit more tricky type of shit here. Okay, all right. So osmium tetroxide with a fat fellow hydrolysis. Fat fellow hydrolysis. Honestly, I have no idea. Doc. My gut feeling tells me that this is going to be one of those terminal cases over here. Possible terminal case. Let's collect data over here. What is the answer given for this question?
A.
A. Then it is nothing there. Then there is an obvious thing there. Then what is the problem there? Then osmium tetroxide hydrolysis only. Now then, so if answer is given as A, what's the problem? There is only one. No, there is no problem at all. There's obviously that only there.
Yeah, but what does the other side will do though? That's
gives a shit.
Okay.
Seriously, I'm asking you why. See, you find a random dude on the street who's using a toothbrush on the road. On the road, not what to say, using the toothbrush in that fashion. He's taking the toothbrush and cleaning the road with it. How does it matter what the fuck he's doing?
Yeah. Okay.
You understand the idea there, right?
Yeah. The solution says cis-2-butene when undergo syn addition gives meso compound.
Yep.
Yeah.
Basically, the same osmium tetroxide is doing its normal shit.
Yeah.
So normal shit is done. Why should you care about what is the normal thing there then?
Yeah. Okay. That's it, I guess.
The normal hydrolysis instead of NaHSO3, they are doing something funny. I thought it was some weird shit and some new thing was going to be learned over there, but looks like nothing new really. Okay, all right.
Yeah.
What is the major product of the following reaction? What's your problem? What's your issue here? What are the options given?
Sorry, my bad.
Huh?
Sir, I had it.
Okay. NaBH4 के साथ ना, okay, COH and double bond over both there, and we are going to be having which one undergoing attack by the NaBH4. What's your problem here?
Sir, how can you tell whether it's syn or cis? Sorry, syn.
Both are going to be there, no? How does it make a difference which one it is? You'll have both.
Major product. Asking that single correct.
Are they asking for major there? Did they mention major?
Yes.
Major product. Okay, all right.
So what I thought was
one second. The COH will mainly exist in the form of CO minus here. Okay, so it will repel away the NaBH4 which is approaching. So if it is repelling away the NaBH4 which is approaching, predominantly the H minus should attack from the opposite direction as the CO minus. So the H minus attacks from opposite direction as CO minus. The O minus should be same direction. Answer is Bombay.
No, sir.
A is given.
A is given. Then I also thought it was Bombay.
Sorry.
Sir, what I thought was maybe if you see the conformer and they both have to be equatorial. I thought something like that. Like equatorial is always more stable.
Wait. अरे भाई तूने चूतिया पाई किया है. That is not a wrong logic. That is the correct logic. I only fucked up here. You were on the right track, but you fucked up in the equatorial part there. Your logic was not wrong. So more stable compound is the major product. Perfect. Not bad at all. So more stable is going to be equatorial. Correct. So equatorial
But
is
how do you
going
know
to be
whether?
same side only. These two are equatorial.
But they could be axial also, right?
Yes, it can certainly be axial also.
Okay, but then that's not
Obviously,
given
it'll
as
go
the
for
right answer.
equatorial instead of axial, or it might go for axial and maybe get some hydrogen bonding out of the way there. Who knows? But same side is going to be more stable technically. Equatorial is better.
Oh, yeah. Maybe hydrogen bonding something. Okay.
Hydrogen bonding will not happen in 1-3. Not that easily. Not that easily. Very far off they are. Opposite
In the
direction.
answer it says transform more stable major
No.
product.
They can't do boat. Boat is 1-4,
Hmm.
not 1-3. 1-3 is not good for hydrogen bonding. 1-3 will be
Okay.
opposite directions. Equatorial is best. And
Hmm.
option A is going to be axial equatorial.
Yeah, that's what I was thinking. But answer is given as yeah.
Axial equatorial is not that good. Equatorial is better, no?
Yes, sir.
So this will be axial. This will be equatorial. That logic is the correct way to go. And yes, answer is Bombay. Oh, still answer is Bombay. What the fuck? They gave answer as A?
Yes, sir. Yeah.
No, then that also doesn't work then. Either way, my logic is also giving answer as A, and this is also, if I look at it, this is also A only. No, this is something else then. Are you sure
Okay.
they are given A as the answer?
Yes, sir. Yeah. It says transform more stable major product.
Repeat.
Transform and then in brackets more stable major product.
Answer is Bombay Danda, not A. This is the transform here, not what they are saying. Equatorial is better here, not axial equatorial, because the cyclohexane here. So when they say transform there, they mean that the more stable structure only there. So from that point of view, answer is Bombay, not A. So their answer is wrong. Their logic, if we are looking at it, according to their logic, answer option should be Bombay.
Okay. Yeah.
Okay, next up.
I sent the next one, sir.
Yes, have a look.
Oh, I did that. How
How many more do you have for today?
Just a few more, sir. Almost done. Oh, right there. Wait. Sir, they
Send them
gave
on.
like
Hmm?
they gave like a few alcohols and they said which is oxidized most easily. One is phenol, one is uh, isopropyl alcohol, and one is an ether, diethyl ether.
Diethyl
Phenol.
ether is given.
Yes, sir. Phenol.
Phenol does not undergo oxidation at all.
And then ortho, wait. One methyl, one hydroxy cyclohexane.
One, what is the
Hexane.
cyclohexane? Okay.
CH3OH on same.
One methyl.
One methyl, one hydroxy.
Okay. This is the
Yeah,
compound.
which is most easily oxidized.
Obviously, diethyl ether.
Just now, oh, answer is given as isopropyl alcohol.
Well, if you're looking at the product of oxidation being one of the compounds which you will be getting familiar with, yes, among the alcohols here, this is the easiest to oxidize. So first is going to be this, second is this. There is no third and fourth. Both of these will not undergo oxidation.
Yeah,
Right.
it said that
This is
fluorinated
tertiary,
alcohol.
this is phenol, no oxidation. Why did I go with diethyl ether? Mainly because it forms the peroxide.
Perox.
It forms this, which is an explosive substance. All ethers, generally, when you're going to be using ethers in the lab, you have to be very careful when you're using an ether. You should not be heating it directly, because when you heat it directly in the presence of oxygen, it will end up
Peroxide.
forming this peroxide, which will explode.
Yeah, very explosive. Yes.
So this shit is something which can realistically form. So no, oxidation of ether is very easy, very dangerous. So yeah, among the options given, I will still go with the ether if it is a JE type of question. For our our purposes over here with respect to just oxidation, yes, among the alcohols, this alcohol will undergo oxidation easiest. Among these, alcohol oxidation will be better if you're going to be having higher delta plus. Depends on what is going to be the oxidizing agent. That also does matter. Lesser steric hindrance usually will result in more easier oxidation. Next up,
I sent it, sir.
you've sent. Have you done Pinacolone reaction?
Yes, sir.
You've done Pinacolone.
Oh, yeah. Yes, sir. Yeah.
Yes or no?
Yes.
This Pinacolone.
Oh.
You'll have the nitrogen gas leaving.
Nitrogen gas leaving.
Having carbocation rearrangement, then Pinacolone.
Sir, don't you have NH3 gas leaving?
No. What is the reaction there? You look at the reagent there. It's HNO2.
Sorry. My bad. No, not NH. That's something else.
You get diazonium. Diazonium will kick out N2 gas. You get carbocation. Carbocation then ends up performing the Pinacolone shift over there. Pinacolone, I think you have learned. I think we have already discussed this before, now. Carbocation rearrangement, priority order, and all.
Yes, we have. A while back. Okay, I didn't think. Okay, 1 second.
This was an old JE question. I don't remember which year. Something like this was asked before, both either in JE mains or in JE advanced.
Okay.
It was asked in JE advanced. It was a simple question. Mains would have been a good question. Next up, this is very straightforward. They are clearly telling you constitutional isomer. What does constitutional mean?
Like same. It's basically isomer.
So,
sir, like my note was.
What does constitutional isomer mean? That is your real problem here.
No.
Yes. Yes.
What takes place? Like this H plus, where did it attack? Or that's what's happening.
Let me just confirm what these are. So constitutional formulas, constitutional isomers are going to be basically nothing but same molecular formulas, nothing else.
Yeah.
So now in this particular case here, what is going to be happening here is very straightforward. The H plus here, it can attack in many different places. It is not going to be necessarily attacking only one spot. What you have put over there as 3 locations of attack is very much feasible. But the real point over here is, what is compound B? What is the most feasible compound B? That is a real question here, correct?
Yeah.
So stop thinking about what should happen. Nobody gives a shit about that. All you have to do is check about probabilities now and play that game. Look at the options. Option A, is that feasible? Yes, it is feasible. So in this question here, how should you approach a question of this sort here? Not by looking at what all can happen. No, this is a shit question if you look at it like that. Your job is to get to the answer here. Look at the options and decide based on the options here. So first one here, option A, you're having...
How is it feasible?
Yes?
How is the first one feasible?
Dude, did I say it is feasible?
Yeah, you said.
Looking at each of them, we will consider each of them on their merits. Don't jump the gun. Now, so first here in this case here, option A, you're going to be having the oxygen is basically going to be replacing the nitrogen there, correct? So what should have happened here if this should happen? If you want to get A from that, what should happen? The OH group should come and perform a nucleophilic addition, then followed up by a nucleophilic elimination of the NH2, correct? Yes. Or think? Yes. The OH should be performing some kind of a nucleophilic addition reaction on the carbonyl there, and then the NH should be leaving. Right? For me to get something like that?
Yes.
Does that sound sensible?
Yes.
Fuck no, that does not sound sensible to me. Yes, it is possible to do, but that doesn't sound sensible. Why is that nonsensical to me? Why does it not make much sense to me over here? Why am I not agreeing with that being sensible? Why am I
The
saying that doesn't make much sense?
there's resonance.
Huh?
Resonance.
Yes, nitrogen's resonance is much better than oxygen's resonance. Why would the
Yes, sir.
nitrogen leave? Nitrogen as a minus is worse than an oxygen as a minus.
Hmm.
Nitrogen leaving is not feasible in much of those cases over there. So now in this particular case here, option A seems not that great if I look at it from that logic directly. But let's look at option B here. Option B seems even more preposterous. It is assuming that option A has happened and then some more funny business is happening. Correct?
Yeah. Yeah.
So option B seems nonsensical by a good margin. Option C seems even more nonsensical. Right?
Oh, this valency is actually not even
Yep.
satisfied in the third.
It's completely gone there. Right? And
Yes, sir.
option D, what should have happened if you want to get option Delhi there?
Uh,
Option A obtained, and then I should do some funny business, and then the nitrogen should do a double ring, and then somehow some more. I don't understand how that should happen there. So, what is the most commonsensical answer here? If I have to give an answer here,
A.
correct.
Yeah,
Job
that's the
done.
answer.
No, there's no possibility of anything else being there.
Yeah.
A itself is preposterous enough that it should not happen.
Yes. Okay.
And after A, only B and C can come. And D even more, even more beyond that. So it's all about using your brain in questions.
Okay.
Bulk of the time.
I should. Okay. Hmm. I said the next one, sir. Yeah.
Yeah. H2CrO4, Jones reagent. Okay. Now you're going to be having a tertiary alcohol.
It won't get reduced. Oxidized. Oxidized. Oxidized.
But you're having a double bond there, C double bond C.
Yeah. How will you?
You'll get something like this guy first. Can I have something else happening from here? No. So any of the possibilities among the options given there? No, none of them seem feasible there realistically. No reaction, Ra. None of these are
That's right.
feasible.
Sir, it said that there will be a loss of water. So carbocation will form, and then resonance will happen, and then 2-degree alcohol, and then ketone.
Let's see there. So if I end up scrapping this completely. So we are going with carbocation. Basically, they are saying that this is okay, but this becomes OH2 plus. We get that guy getting out. So we get
Does H2CrO4 do that?
no, acidic to have so possibility is there. So we get this. So now resonance happens. They are saying from here we get something like this now. When I get a carbocation here, this they are telling will undergo hydrolysis. Then this will become this. Then they are telling this will undergo oxidation. Is that the argument there?
Yes.
Feasible, but I doubt it is going to be realistic because you're going to be having too much happening here. Rearrangement has to happen. And more critically, it has to go from a very much more stable carbocation to a less stable one.
Yeah,
Because
that's what.
this is a more stable system.
Exactly. Yes.
So I doubt this shit is still feasible.
Okay.
Elegantly interesting, but no, not good enough.
I
If
sent the next one.
if no reaction was not given as the option, then I would have chosen Bombay for the sake of going about something. But if I'm given no reaction, that is like they are covering their ass over there. So I know for a fact they are not sure. So
Yeah.
I would much rather go with my gut there. This is something you cannot answer now, Ra.
Okay.
You cannot answer this now. I'm talking about the next one, the 18th question, the resource
Yes.
synopsis.
Yeah. 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 That's
You cannot answer that now. That is a much more complicated reaction there. Yeah, it is a much more complicated reaction than you think. Not
okay.
at this stage. Once you have learned a little bit more about what to say aldehydes and ketones, then we can go, because this is going to be something which is going to be an enol actually. So you can think of this as an enol, where you are technically going to be having, how to put it,
Keto and all.
yeah, ketoenol tautomerism being possible
Yeah. That's true.
with this bugger here, something like
Oh
this.
yeah.
So this CH2 over here is going to be the one which is going to be getting kicked out. So this will get out completely as a CHI3. And these two other ends, these two carbon ends will become carboxylic acids.
Hmm.
You understand the idea here?
Yes, sir. Yeah.
It is a little bit more complicated than that, but it can perform the haloform reaction internally.
Okay.
It's a much more complicated one. Okay, 14, 15, and 16. Huh?
Yes, sir.
Okay, all of them are pinacolone.
Yes, sir. Yeah. Some weird stuff they give in the.
Yes.
Okay, could you do the first one?
Yeah, which one do you want me to go with?
All of them.
All of them. Okay, all right. Let's start off with number 14 first. So you're going to be having one of the OHs basically gets protonated, the other guy has to basically shift. Now the question is very simply which one is going to be shifting. All right. And shifting area, the priority is very blunt and simple. When you're doing Pinacolone,
Yeah, HR.
first off, at every stage, the only thing you care about is carbocation stability. Okay. So the idea is very blunt and simple. In the first place, also, you'll go with the most stable carbocation. In the second place, also, you'll go with the most stable carbocation in every point. So if I'm going to be considering the two OH groups here, which OH group is closer to, which OH group leaving will result in the most stable carbocation? The one closer to the plain benzene ring or the one closer to the OMA? OMA. So we are going to be having that fellow getting protonated. That fellow will leave. We get a carbocation there. And then we have internal pinacolone happening, which is basically what more or less you have tried to accomplish over there. So let's try to go for the step over here directly. I'm going to put the product out straight away here. Actually, I can't put the product out straight away. There is no possible way of putting the product out straight away. So I will have to break it down individually only. Okay, so no other option. So carbon, 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 carbon here and a carbon here. Okay. So we're having an OH here and we're having a pH here. And we are going to be having, this is going to be having an OH as well above and a pH below. Interesting. Okay. All right. This time though, it's a pH with an OMA. Okay. So let's say this bugger gets out. So this fellow will leave. We get a carbocation here. So now when you're going to be having a carbocation here, you'll be having rearrangement happening. Now, which you have to get a carbocation on this location here. So this carbon has to lose one of the bonds. Which bond is this guy going to be losing?
The pH.
Hmm? Sorry.
All right.
So you got 2 electrons here, and you got 2 electrons here, and you got one of these 2 bonds has to go.
Sir, but then there's a condition where the migrating group should be anti to the leaving group as well, right?
Sorry, no, what now?
Migrating group should be anti to the leaving group, right? Is that?
Migratory group should be anti to the leaving group. Not necessarily. It is going to be necessary only when it's a concerted step. Not under all circumstances, as you assume. And among the options here, I do not see anything where there is going to be a 3-membered ring left over. So
Yeah, that's.
I would much rather not do any phenyl shift nonsense over there. I would much rather do something much more basic and simpler. And what to say? Directly go with the breaking of the 3-membered ring there, which means this will shift here. See, this carbocation is the desperate fellow, correct?
Yes, sir.
So what is it going to be doing? It is going to be attracting all the bonds on its neighbor. Problem, there are 2 neighbors for that guy. One neighbor over
Yes.
here and one neighbor over here.
Okay.
So which fellow can it attract? It can attract a methyl over here also, or it can attract from this side over here. From this fellow here, the OH is going to be the one which will stabilize the next stage of carbocation.
So it has to.
Can attract either this bond or this bond. These are the 2 main bonds here, correct? If I assume that only the OH is going to be playing a role, then I'm going to be having only 2 pairs of electrons applicable to play with, this pair or this pair. One of these has to go.
Yeah.
If I remove this here, I will still be left over with a 3-membered ring. Being left over with a 3-membered ring is not good, right? So you will end up having this basically shifting being the more predominantly easier thing to do. So let's do that and then see what happens, because the game here is going to be far more complicated is what I sense. So let's do that and see what happens first. So you get PHC. We get double bond O appearing over here because you'll be having the pinacolone obtained over there. You'll get a carbon here. No, we'll be getting double bond here now though. No. Oh, so with OH, okay. I'll be having carbocation here. Okay. I'll be having this bond shifting here. That bond shifts there. Oh, that bond will not shift there. That bond will shift in the other direction. Okay, so this is wrong here. I did not draw this correctly. This will shift here. Not in that direction. If it shifts in this direction here, we will be having carbon, double bonded carbon like this. And I'll have PHOME connection here. This bugger will become C double bond O, which means this will become PH C double bond O, C double bond C, single bond C, single bond C, and this fellow. But none of these are the options here now. Or is it still one of the options here? No, none of these are the options here. So in this particular case here, they are not going with this shifting. Okay, they are going with the other one only. So if we are going with that type of a shift happening, carbon OH. It is easier to basically check which is going to be the more apt pinacolone product, and then basically directly guess. Bombay is out. Elimination lab Bombay will be out over here. We are going to be having among the other options here. What is the possibility of not working out over here? Option Delhi is out. Why is option Delhi out? Aman, you're still here?
Yes, sir. How is the methyl? There's a methyl on the benzene.
Yeah, the extra methyl, correct. So basically Delhi is out there. So we are having A and C as the possibilities which are left over now. So we have to guess between A and C here. A is a more easier thing to guess because A has to be the one which is going to be having some funny shifting happening there. OME should not be doing any funny business there. OME will remain as it is because OME will be the first carbocation formed. So that fellow will not do anything. So answer should be A out of C there, between A and C. What is the given option though? A or C?
Yes, sir.
A.
A is given.
Then basically we don't need to do any guesswork here. I have no idea how this pinacolone really works there. Most probably some weird shit should happen over there with respect to this carbocation and this particular, what to say, C double bond C. My guess is this will rearrange now. Instead of this step happening here, that is, mostly this step will not happen. What will happen after that will be more interesting from here. Mostly this will rearrange to become something like this now. So we'll get PHC, double bond C, OH, single bond PH OME. And I'll be having carbon, carbon, and carbon. I'll be getting a carbocation here. This carbocation will now do EAS. On
Yeah,
this,
that's what the difference is. Yeah.
you understand the idea as to how they are going to be getting the product over here? Finally, how to get A?
Yes, sir. Yeah.
So once you do EAS, after the EAS is done, the next step is going to be enol. Enol to
Yeah.
ketone. You understand the reaction as to how they are going about things over here?
Yes, sir. Yeah.
So they are basically choosing this pathway only. That is, this bond is shifting here.
That one. Exactly. Yes.
That is the pathway they are going with. It is just a little bit more convoluted than you expect it to be. That's all. Okay. So the game is very simple. Let me quickly give you what is going to be the only thing you check for in pinacolone: carbocation stability at every stage. Okay, every single stage. The more stable carbocation has to be formed. That's all.
Okay.
Now, 16, 15, and 16. 15 is fairly obvious, Nada.
Sir, why can't it attack the OH? Why is it attacking? Where will the H plus attack?
It can attack anywhere. Why do you want it to attack only one place?
I mean,
think for a second. The H plus will attack where na? It will attack the location which is going to be most efficiently stabilized. Nothing more, nothing less. So in this particular case here, when you are going to be hitting the H plus, what did I just tell you just now? What is the only thing which you should follow?
Carbocation stability.
Good. So carbocation stability is the only thing you're going to be checking now.
First step.
Everything. Stop. Don't think too much. Stop. Just don't think. Now, if I attack here, okay, I get this leaving. I get a carbocation at this location. Correct? That is the competition now. That is one possibility. Now, if I attack here, I will have this shifting here.
Yeah.
Carbocation here.
Yes.
Yes?
Yeah.
Now, if I get carbocation at this location here, with the OH2 plus leaving out, I get a normal carbocation, nothing else. There is no stability for that shit. But if I get a carbocation here at this location after this kind of a shift, the oxygen can stabilize.
Yeah.
So which one will happen there? Only this will happen.
Oh, sorry. Okay. Got it. Yes, sir.
Your only job in any reaction which involves carbocations is to only be religiously looking for carbocation. Nothing else. No more, no less. Fair?
Okay, sir. Yeah, I got it. Yeah.
So 15 ho gaya hai then is what I'm going to be assuming. Yes?
Yes, sir. Yeah, 16.
16. Same shit here again. You'll end up having carbocation being the priority at every stage. So let's have a look at the compound here. The compound is looking like this, where you're having an link like this. Okay, now awkward fellow. Okay. Okay. And we have a double bond over here. Okay. All right. So you're going to be hitting it with H plus. H plus ke saath kya hoga? We'll end up having this becoming OH plus, and one of the bonds has to break. Which bond will break is going to be the next question here. So which bond will break? You think and tell me. Let's say I get this to become OH plus.
Yeah.
Okay. Now something has to break.
Yes.
Now, if I break,
more stable carbocation again.
what is it? What has to break here? We have to result in some carbocation. Where are the possible carbocation locations? Here and here.
Oh, there are. Yes.
These are the two locations for carbocations.
Yes.
Which is a better location for a carbocation? Carbon 1 or carbon 2? 1 is better because 2 is closer to a double bond.
Yes. Yeah. Yes
or no?
Yes.
So I will be having product obtained here. In some ways, it will look like this. One I'll be getting carbocation, which means these two electrons will be taken over by the oxygen. Correct?
Yeah.
So carbon, I will get OH. And this carbon here is going to be attached to another ring here like this. I remember, no? Now we are going to be having a double bond over here. Okay, this is what we get along with a carbocation at this location. Fair?
Yeah.
Now, what will happen? This carbocation has to shift now. Pinacolone type of rearrangement should happen now.
Yes.
So if that type of rearrangement should happen here, what is going to be the most sensible type of step over here? Something has to be attracted. One of the three bonds on this has to go. Correct?
Yeah.
Which are the two bonds now actually realistically available? This is one bond and this is one bond.
Yes. The
Correct?
carbon bond is more accessible.
So which one is going to be shifting here?
Carbon.
Correct. You can proceed from there, right?
Yeah. Then yeah.
Yes or no?
Yes. So it won't attack the double bond O hydrogen. The hydrogen won't attack the double bond O.
What hydrogen now?
No, initially I'm saying.
Even if it does attack, will it do anything from there? Think. Will it do anything from there? It might attack for all we know, and it probably will attack. It will just become an OH plus and it will take out the H plus and be reversible with it. That's all. Yes, correct. So the idea is not about whether it will attack or not. The question is, if it attacks, can it do something for me? Is it going to be leading to something else? That is the real question which you need to start answering. It is not about can it attack. Of course it will attack. The real question is, can it result in something which is going to be more meaningfully yielding different products? If it is not, don't care.
So then the final product would be option B.
That I have no idea about.
Sir, because when I did it, I got option B, but answer is given option A.
Wait, let me try. I'm not sure. Okay, so this is going to be a little bit more trickier than I expected. I have to number now. Whenever you are going to be having any nonsense like this happening, it is always better to number them. So 1 is connected to 10 now. Okay. And 1 forms a 6-membered ring with the other side. Okay, so 1 is part of a 6-membered ring and it is connected like this. Okay. So carbon 1 is part of a 6-membered ring now, and that guy is going to be connected to what else? It's connected to 6, 7, 8, 9, 10 exactly in order. Okay, perfect. So 6 here, 7, 8, 9, and 10. And we are going to be having 10 having a double bond O. Okay. And 6 is having an OH. And 6 is going to be with a positive charge. 6 will kick out. 6 will also get a double bond O. Okay. So this will be my product. Well, what is the correct answer option given?
Yes, sir.
What is Ada?
I'll send the mechanism.
6-membered and 6-membered. Interesting, interesting. So they are saying after that happens, one more funny business happens. Very interesting. Okay, try करते हैं एक और बार then. चलो, so instead of going there, I will have OH here and a plus charge here. Okay, so let's continue from here. So from here, so this is the product we have gotten obtained as of now, correct? I basically assume that yahan se it will directly go into a double bond over there. But since none of the, what to say, compounds given, are there any options like this? No, none of the options are this. So since there are none of the options like this, we'll have to do one more step now. So in this case here, what's going to be happening next is we are going to be having this carbocation here, correct? So this carbocation, why would it shift now? It should not. Oh, okay. It will shift because of 5-membered ring and 6-membered ring. Okay. So there's a 5-membered ring over here with a 6-membered ring possibility, ring expansion possible.
Yeah.
Ring expansion will happen now.
Yeah, that's what we did, right?
No. Here we are having this as a 5-membered ring. This was basically the original thing there. That was not a ring expansion we did here. This was basically Pinacolone attack over that type we did over here. Carbocation rearrangement, one form of ring expansion we did. Now we are having the same thing again applicable now. We are going to be having this ring now here, correct? Think of this ring now. This is a 5-membered ring with a 6-member, what to say, carbon with a positive charge outside. So we have one more expansion possibility.
Okay. Understood.
So we'll have one more ring expansion happening, and then finally we'll have the, what to say, output basically delivered based on that.
Okay.
So वापस एक और बार करना पड़ेगा तुम्हें.
Yeah, I got it now. Yeah.
Try it out yourself.
Yes, sir. I'll do that.
Next up.
That's it, sir. Nothing else.
I think, yeah, this is more or less what we are getting now. I think they are getting that only, and then from there we have to get once more.
Yes.
Now, next up.
That's it.
That's it. So tomorrow you have the exam in the morning or in the afternoon?
Morning, sir.
Morning. And उसके बाद छुट्टी है कि उसके बाद classes?
No, sir. Classes.
Good luck then. Don't bomb.
Yes, sir. Yeah.
And remember,
Yes,
whatever you are basically, what to say, look at it as, what to say, how to put it, diverse yourself from the outcome as much as possible. In a sense, you give yourself the best effort as much as possible before, during preparation, put in the best foot forward during the exam. After the exam is done, don't care. It has to be a different person, a completely different person analyzing the results of the exam and how to improve. The person who's writing the exam and preparing for the exam has to be a different person. Okay, all right then. We will close today then. Any other doubts you have in inorganic, anything else?
No, sir. Nothing else.
You're done then?
Yes, sir.
Bye bye. Have a good day.
Thank you, sir.
Good
You
luck
too,
for your
sir.
exam.
Thank you, sir. Have a nice day.
Yeah.